Thanks, Leonard, for the introduction. I and Ilaria will bring an industrial perspective to the sustainability focus of this meeting. And we will do by adding one more dimension, which is that of safety. And we will see how these two concepts are actually integrated, but are not the same thing. And we will also talk about the design of safe and sustainable products or processes. With design, we mean trying to turn upside down what is the conventional approach to safety, to sustainability, which is actually we first make products, we get it onto the market, and then after that, we check if it is safe and sustainable, and we try to go back and adjust things. In this case, the approach we want to illustrate is to start at the beginning to integrate sustainability and safety into the design of new products or processes or services. Why we need to talk about that? So one reason, which is I think we are all aware of that, is that climate is changing. Here you see the spectrum of the temperature, the trend of the rising temperature. This is a piece of a famous cover of The Economist magazine that popularized the climate change some year ago. So the climate is changing. But there is also another aspect which is not directly related to climate change. It is that of safety. This is the map of the contamination of PFAS, which are a peculiar molecule in Europe. If you want to see the focus on the UK, you can get an idea of what the situation is. And this is a typical example or an extremely performing material, extremely performing molecule, but with the dark side. It is also very dangerous, which we can find in the water of almost all Europe. And statistics says that everybody of us right now in this room has some part of PFAS in our blood. So we need to do something. There is another aspect that, in my opinion, is often overlooked, is that unsafety and unsustainability cost some money. Think to the cost of withdrawing a product from the market because we discover later that it is unsafe, or to the cost of reputation for not doing sustainable manufacturing, for example. So this aspect costs money to the company. I know only one type of industry that is unsafe and unsustainable by design. That is the military industry, but this is another type of issue. So here there was a slide about our presentation, but I think that Leonard did already a great job. I will skip and try to get already into the main focus of the topic. Main point of our shared presentation. So the carbonization is not just cutting emissions. It's not just making chimney smaller and smaller, but it requires a redesign our production and consumption of goods. And this will be part of the talk, how to do that. Also, focusing on the design, it involves some type of prediction of anticipatory risk assessment, as we put here, trying to look ahead to avoid to find ourselves in the condition of discovering that something is unsafe or unsustainable when it's too late. We can just think to the tobacco story or the carbon story. And by experience, I know, for example, that We have nanoparticle already on the market. I think we are surrounded by nanoparticle, although we don't know, but still we don't know what's their effect on our health and on the health of the environment of the planet. So we will show some method, some approach to be able to say something in advance about the risks that we will face. And we will show a practical example of how a technology can be designed to be safe and sustainable before it actually exists. This is the short agenda. We will focus on the concept first, just to reinforce some idea. We will focus on the design strategy, which is the core of our presentation, and we will show a practical implementation of what we have talked about in the case of the hydrogen production. So let's go to the core of the presentation: safety and sustainability. If I will ask you, can you tell the difference between safety and sustainability? I can invite you to drop, if you have some idea, in the chat. And we will read while we are doing that, because these are two concepts, as I was saying, they are intimately linked, but they are not the same. We can have something, okay, that is safe, although it is not sustainable, and vice versa. So what are they? What are we talking about here? I don't see the chat. If someone is dropping some answer in the chat, I can wait a bit.
Yeah.
So safety is a non-compromisable, but sustainability might be, example, Kevlar jacket. That's one. Yeah. Please keep them coming. That's the first one I'm seeing.
I'll leave you 10 seconds more so we can share some idea. I'm asking these questions also because, especially in the case of sustainability, it's not always straightforward to define rigorously. It is a kind of squishy concept. That's why I wanted to challenge you to see, okay, do we have the same idea? Sometimes I myself have some trouble in finding a right definition of these things. So let's go ahead, and we will actually, I will show you. Okay, I see now I can open the chat. Safety is preventing harm. Sustainability, care the planet. Okay. Safety, protect human life, right? Safety is not compromisable, but sustainability may be example of Kevlar jacket, what we already say. Okay, these are all correct. I will say, I will try to be a bit more rigorous. So just to give you an idea of how these two things are related, but still different concept. I use this, think recognizable yin and yang metaphor about the safety. Now, safety can be rigorously defined. It quantifies numbers, their measurements, experiments. What is the exposure and hazard of a material, of a process, of a service. So the hazard is the potential harm that something can do. But for having quantifiable risk, we need also the exposure. Exposure is the probability that that dangerous thing can reach a biological target. Let's think, if I have a rifle bullet of my desk, the hazard, so the intrinsic damaging potential is very high, but the exposure is low because it's very difficult that this bullet can reach and damage something else. But as soon as I put the exactly same bullet in a rifle, then the risk becomes very high because the exposure, the probability that the bullet reaches a biological target is very high. And safety goes actually to the quantification of these two aspects, sometimes or very often down to the molecular level. It also analyzes different exposure scenarios. Actually, risk giving the same hazard, there are multiple ways that dangerous things can reach us, our body, of the environment. And something that we need to keep in mind, safety is based on absolute metrics. As I was saying here, there are numbers, there are thresholds, there are experiments and measurements that need to be done. Let's go to the other side of the coin, which is sustainability. Sustainability is has not such a rigorous definition as safety because it takes into account many aspects and often is a systemic evaluation of a situation. It evaluates, this is a very important point, also the social and economic factors also, which by given their complexity, sometimes very difficult to quantify with rigorous metrics. And it addresses the entire value chain. The life cycle assessment is a very, they are becoming very popular tools in this aspect, but there also there is some uncertainty. So the two side of the coin go together, and although they are functionally interdependent, they need to be true at the same times in our perspective, but still cover different things. So how are risk managed? This is another question that I wanted to ask you. At which point risks here intend in terms of safety, in terms of sustainability, traditionally in the traditional industry come under the microscope, according to your experience? If someone has some idea, you can put in the chat again, so I will be able to see. True risk register. Yeah. The idea I was thinking about is that usually, as I was saying at the beginning, and is also I observed the same actually conclusion in some talk today when there are other type of problems when the emphasis, when the urgency goes to efficiency and schedule, sustainability and safety often go at the bottom of the list of to-do things, and sometimes they are really not put into the consideration. So our traditional way of dealing with these aspects is to first focus on performance and efficiency of the production process, of the process itself and the services, and neglecting the sustainability and safe safety sides. This is just the example of the PFAS I was just illustrating at the beginning, but this is true for most of the things we buy in a supermarket today. First comes the quality of the products, and we don't care about safety in the phase of designing the products, and we just try to mitigate the safety, the risks or the unsustainability if it emerge, because it can remain hidden. And we know of many, especially professional disease that emerge 20 years after some worker has worked for 20 years in a high exposure environment, some industrial setting. So we want, as I said at the beginning, turn upside down this perspective and illustrate you how to forecast the risks. And the ideal part is to do it before, even before the products exist, just to have an idea of the risk that it might face and try to find a solution before actually the risks emerge in the reality. This is the core of what is called the safety and sustainability by design approach, which I want to illustrate to you. First, the safe and the sustainable by design approach want to combine the sustainability side, so environmental side, the social side, the economic sides with safety. You see in this slide, the safety just on top of the other aspects of the products we want to build, and to do it before we start to produce the products. So even we can use the safe and sustainability by design approach to decide if it is worth to produce something or not, because we don't want to be in the condition of producing something that we need to withdraw from the market in a couple of years or do damage to the workers or to the users or to the region where these products are manufactured and produced. Here I want to illustrate you what are the steps of this safety sustainability by design process. We need to start from an hypothesis of products. We need to start from somewhere. We need to have an idea. And you as manager, you want to explore some new opportunity. You need to start somewhere. At that point, once assuming we are developing a new product, we need to define it, to establish the function. It is called technical function rigorously, that the various ingredients will do in our product, especially for those that are potentially harmful. We need to say, okay, why I need that ingredient? I know that it might be dangerous, but why I need? What is the function that these components has to be good at? And is the first step. Once we have defined the function and have an hypothesis of products and ingredients, we start with the assessment of risks which go to the safety part of the story. Assess the hazards, potential hazard, if it is a new ingredient, a new molecule, a new product. So we need to find by analogy with similar products, with similar substance, to have a evaluation of potential risks and analyze the exposure parts, including the manufacturing part, which means the occupational risk while the products will be produced. This is a very crucial point because workers are exposed to high amounts of dangerous or potentially dangerous materials or substances. That is really important. And then analyze the possible exposure during the use and in the disposal and in the waste section. Try to have an idea of that risks. After that, we need to evaluate the sustainability side of the story. So run a life cycle assessment, see where the raw material come from, how sustainable the production this raw material is, the social impacts of the product itself and of the way of producing it. What are the economical impacts also in the long term? Is really worth to produce these potentially hazardous products or material? That is the answer we try to ask here, and we combine. Then we reach a critical point that often at least manager who work in the traditional industry don't want to hear often, because once we have established the function that we need and we have run the safety and sustainability evaluation, we need to find a balance between the two things. That means that is not rare the case that sometimes we must sacrifice some efficiency, some performance in order to ensure safety and sustainability. And this is, I think, in my opinion, the revolution of this approach, because we never did the industrial, development of the last century, just focused on the function, focused on the amount produced. We didn't care about the consequences. And now we are actually in troubles. Think to the emission of CO2. We didn't care, what all this CO2 could do. Okay, we didn't know in some case. In some other case, we knew exactly. In the case of the PFAS, we knew what they were. But still, we focused on the profit and efficiency and quality of the products. Here, the challenge is to balance these two things, make things a little bit less performing, sacrificing some efficiency, but ensuring the safety and sustainability. Based on this information, we can redesign our products. We started from an hypothesis that we needed to run all these steps. Now we are in a condition of redesign our original idea and test if all the conditions are met. It might also happen that we need to rerun the cycle again. I want to attract your attention to two aspects of this slide. First, the title, up there is process. The safety and sustainability by design approach is a process. What I want to say with process, actually, first, the steps don't need to be in this order. They change always, and they inform each step from the results from the previous step. But it's, as I said, is a process. There are no recipe in this field. There are no rational and logical schedule in this set. That's why there is no algorithm or even AI agent that can run this cycle. This is something that I heard in many presentations today. Algorithm and AI can assist the manager to take good decision, and they are really great tools for this aim. But the last word is still a human word, and it's the word of the manager. And then if you look at some of the red words, okay, hypothesis, assessment, evaluation, redesign. So they are telling us something, that there is a great uncertainty involved in this process. And the scope, the goal of this approach is not to, as I said, get the recipe, to get you the recipe for making your products, but just to reduce this uncertainty. That will be always there. Uncertainty is unavoidable to a certain level for many reasons. First, because the products probably doesn't exist yet. The new materials are not tested, and this happened with many chemicals on the market, for example. They are not all tested. And we know, if you think to asbestos, that we discovered that is, dangerous after 20, 30 years. But now we have that knowledge. We know where to look. Think that each of these steps here is a discipline by itself. And the experts of each step do not talk the same language. I know that by experience. I'm a chemist, and it's very hard to talk to a biologist or to a project manager.
So, sorry, Dr. Felice.
Yeah.
Just keep in mind that Dr. Ilaria will need to
Yes.
come in, and then we'll have question and answer at the end.
Yes.
Thank you.
I'm done with my part. So this was just the introduction to the safety by design process that now my colleague Ilaria will delve into the details.
Okay, thank you, Felice. And I start immediately. If I can find the way to share, here we are. Okay. Can you see the slides?
Not yet. Yes.
Okay. So I try to quickly show you a case study about all the possible implementation of the safety by design concepts and process. Just how Felice has just introduced you. So we started thinking about climate change and carrying the planet. And climate change, as Felice said, is something that comes from the past in which industry, the whole society, let's say, didn't think about consequences of human actions. And we thought that our planet could absorb our activity with no limit. Instead, the limit has been hidden. And we need remedy. We need remedies. And hydrogen is one of the fuel that could be used in future to replace fossil fuels. This is why there's a big attention on this element, on this product. But what we want is to develop this technology and to produce hydrogen in a way that this doesn't introduce another problem in the cycle of our activity. We need to solve the problem, not introduce another one. Very quickly, hydrogen is a gas. But most of all is a fuel. As I said, there's a fuel that has peculiar characteristics that fossil fuel don't have. If we burn hydrogen, we obtain waters as a product. Instead, if we burn fossil fuels, we obtain CO2 that we don't want. So hydrogen is envisioned as a potential substitution of the fossil fuels. The problem is that it's not present in nature, or at least it's present, but it's a very light gases. We can find hydrogen in the highest part of atmosphere, so it cannot be exploited. We need to produce it. And here is the way to produce it already on your slide, because if we burn hydrogen, we can produce water. And this is matter because, this fuel can decarbonize, for instance, transport can decarbonize heavy industries that are powered by fossil fuels at the moment. But water is the resource that the planet gives us to produce hydrogen. Because if we split water in hydrogen and oxygen using energy, we can stock this fuel for our activity. And the energy needed to produce hydrogen must be green and must be renewable. So we cannot, it makes no sense to produce, obviously, hydrogen with fossil fuels. So we have this challenge ahead to decarbonize our economy that is based on production of hydrogen using water and the electricity, the so-called electrolysis. As you can see here, this principle is very simple. Hydrogen can be produced in splitting water through simple, with simple, let's say, conceptual conductive electrodes, which are two pieces of metal that conduct electricity, and this electricity split the water in the two gases, as you can see in this image. This is, let's say, the theory. This is the principle, okay? It looks very simple, like a glass of water with two conductive things and a battery in the middle. In the real industry, a real electrolyzer is a bigger and more complex machine. And this machine has inside a potential harmful compound, which is called nanoparticle. As Felice already introduced before, these nanoparticles are substantially things created by the humans to accelerate it, to make this process more efficient for our economy. But behind this, there's some, let's say, hidden risk, because these nanoparticles are so small, their dimensions are not naturally present in our environment. It is something that we created, like plastic, like other things that can interact with our bodies, with the environment, because the dimension of these nanoparticles that are so active to split water in hydrogen and oxygen are in theory, let's say, able to attack and to process also the water in our body or in our cells. So if we want hydrogen, I want to reason as a sort of project manager. Yes, our economy, our industry need hydrogen, and to have hydrogen, we need to deal with these small nanoforms. So we have to try to do our best to not make this nanoparticle goes around during manufacturing of the electrolyzer, during the operation of the electrolyzer, and during the end of life of the electrolyzer. Because the nanoparticles that are in this device can be released at any of the stage of this operation. So what at the moment is the problem with hydrogen safety? We are thinking about hydrogen safety at the same level we considered the other fuels. We are thinking about leaks of hydrogen, which is very flammable, so it's an important risk to consider. Explosion, storage risk, transport risk. So we are still thinking hydrogen is something similar to the other fuel. Instead, this is not, because we are missing the dimension of the devices that we need to produce this hydrogen. Right? So nanomaterial release, the exposure of people that work on this manufacturing, the long-term toxicity as for PFAS or asbestos. We have that example. We cannot replace the same mistakes with this new technology. And we don't know also which is the environmental fate of these nanoparticles. So we are ignoring the materials that we use to produce hydrogen. What we can do? Use the SBD approach, so making the questions on these technologies before to fully integrate these in our economy. This is emerging, let's say, business, but they are very important. There are a lot of policies in Europe and all around the world that push hydrogen as something that really can solve the problem of emissions in our life. So we need to think about the process. What's the risk in when we design nanoparticle? What are the degradation? What happen at the end of life? Then these nanomaterials, how we can design them? How can the particle detachment can happen? How this particle can be released at the end of the life of this device. And for instance, I think that is now very important, and that is stressed already by some normative, is try to realize this technology with so-called embedding materials that can support the activity of these particles without making them go through our environment and let's say and people that work with these devices. And okay, this is just a SWOT summary of nanomaterials in green hydrogen technologies. They have strengths because they are powerful materials to make hydrogen a possible fuel to decarbonize our society, but we have the weakness and not enough knowledge at the state of the art of what can be the consequences and the threats of this approach. So we are at the beginning of using this approach, so we need to integrate it safety by design immediately in this industry reality. Why? Because this is also, strictly connected to the main SDGs, for instance, SDGs 3 that protect worker and the works environment and health, SDG 7 that enable safe and clean hydrogen, responsible innovations for SDGs 9 and SDGs 12 to support circularity, and SDGs 13, because hydrogen is something that can accelerate climate mitigation, and so is something that is really important for let's say for future economic activity. So the problem and the key message is, let's say, when we think to a sustainable project and to protect the planet, as someone wrote in the chat, we just don't think about cutting emissions, as already Felicia introduced before, cutting chimneys, but we need to also think about the old aspect of a new technology bring to really solve an old problem with a new approach. And these decisions are mainly in the hand of the project managers in the field of hydrogen, but not only in the manufacturing related to the hydrogen production, but also to the hydrogen, let's say, I can say our hydrogen can be a revolutionary actor in our societies. I think that the key insights are already there. Designing safe and sustainable product is all we are speaking about through all these this speech. And the last words, have I already said just a few minutes ago, and Felice remarks earlier, have the last words, due to really try to make SSBD approach in the new economy. We already saw that sustainable innovation did with the simultaneous approach of all these SDGs. And I think that we have a lot of time for reflection now, probably to share them together, but we could be grateful. You have around 10 days to drop some reflection about our intervention, about our meeting using Menti. And we will do our best to the PMI organization to give you a feedback, elaborated your reflection, and let's say summarize what is important for our work, and give you a pictures of what could be the next step to go ahead with your work under the light of an SSBD approach. I think there are some resources about safe and sustainable by design tools that are document. This is, let's say, live link, so you can click on them and download the resources about safety by design approach. Then we have a publication that Felice lead about a specific application of this for hydrogen. And then here are our let's say email and our main contact for any let's say further question beyond the one that we can let's say discuss today.
Thank you, Dr. Parisi. We have two questions in the Q&A. I'm hoping maybe we can spare 2 minutes for those, or we can provide feedback after, once you have reflected on them because of our time. Yeah. So thank you everyone. I think answers will be provided by Dr. Parisi and Dr. Simeon. Very brilliant presentation on safety and sustainability. Everyone, you can access the PDUs by completing the survey. I've pasted the link in the comment section. So please go ahead, complete the survey, access the PDUs. Thank you so much.
Thanks to you.
Thank you, Dr.
It'll be a
Felice
pleasure.
and Parisi.
Bye.
Thank you.